Alpha is related with the resistivity temperature dependence, in which case is called coefficient of resistivity. Coefficient or resistivity. Okay, so that is the case about the circuit. So we go into another circuit element, in which case when the two resistors are put in series, what would happen? When you put resistor in parallel, what would happen? So the next one we want to investigate how the resistors put it in series and parallel. So this one is in the section 21.7. Connecting the resistor in series and in parallel. You can say the resistors combination, resistors in parallel and in series. And you will find out that capacitor and resistors acting will be a little bit different than before in capacitor. So we start out with resistors in series. So we're using two resistors as a background. So here is one resistor, in this case called R1, and this one is a resistor, in which case called R2, and here is the voltage, V. So then we want to find out the equivalent. So here you go. There's two resistors there. How about we like to find one resistor to replace this two resistors? This is called R equivalent. So when we're doing this R equivalent, we have to figure out the voltage across or voltage drop across the resistor R1 is considered as V1. V1 is equal to the current go through it times R1. So we have a current. So when we have like this, there's a current go through both resistors are the same. When you have a resistor, two resistors in series, the current go through both resistors with the same current. So V1 equal to IR1, V2 equal to IR2. So we have the voltage is equal to V1 plus V2. So by using this, so V equal to I times R1 plus I times R2. So in that case, the voltage divided by current equal to R1 plus R2. So we define V divided by R is defined that as R equivalent. So R equivalent is equal to R1 plus R2. If we have two resistors in series, then it's the sum of two resistors. So if you have three, then you sum it up. So all the resistors in series, the resistor in equivalent is, for example, if you have 3 resistors, then equal R1 plus R2 plus R3. Or if you have 4 resistors, just so there's a lot of puzzle for solving this resistor in series, resistor in parallel thing going on here. So the next thing we like to talk about is the resistors in parallel. The one above is the resistor in series, and now we have the resistors in parallel. The characteristic of resistors in parallel for each resistors, the voltage are the same because it's parallel. So suppose the voltage in here, V, this is a positive, and then we get 1 resistors. In this case, it's R1. And then we have another resistor is equal to R2. Because it is a resistor is in parallel, so that when the current goes through here, I, and one of it is called I1, another one go to here is I2. So it, in the junction, is split out 2 components. One become I1, another become I2. So the voltage per se are the same. Equal to I1 times R1 equal to I2 times R2. In these cases, the current I at this junction is equal to sum of the junction. That is a part of the Kirchhoff's rule. If there's a junction in here, the current go in this direction, I, and then if they go in 1 is I1, this go out I2. We will learn about this later on. The current go in equal to sum of the current go out. So that is one of the Kirchhoff's rule. We're going to apply over and over again in our homework and examples. And that turned out to be a very important rule in the electrical circuit. So using this one, and from this equation, we have what is the I1? I1 is equal to V divided by R1. What is I2? I2 is equal to V divided by R2. So you substitute this one, this back to this equation, then you have I equal to V divided by R1 plus V divided by R2. So and then you have I divided by V, that equal to 1 over R1 plus 1 over R2. So from this, we say this, I divided by V is equal to 1 over R equivalent. So for the 2 resistors in parallel, the R 1 over R equivalent equal to 1 over R1 plus 1 over R2. So please look the capacitance up. The capacitance is just the opposite. Okay, capacitance in series is equal to C equivalent equal to C1 plus C2. When the capacitance is in series, then 1 over C equivalent equal 1 over C1 plus 1 over C2. Please using that as a comparison, then you will remember better. Okay. DC circuit. So on section 21.5, we can cover.